This is our first video for Unit 5. What I wanted to do was give you guys a chance to look at some algebra review before we start the unit. We're going to be using these ideas and concepts almost on a regular basis throughout this unit. It's a short unit, only 5 days with a little bit of review, but I want to give you guys a head start. Hopefully this will help you out. So what we want to do is take this line segment with the following endpoints, and we want to construct a perpendicular bisector, and we want that perpendicular bisector to be a line, and we're going to want to find that equation of that line. A lot of algebra involved. I think you guys can handle it. So here are the steps, or here's your approach. What we know is that the perpendicular bisector will go through the midpoint. The midpoint's about right here if you just kind of eyeball it. What we're going to try to do is find that by doing the following. If you look, we have these 2 points here, so what we can do is calculate the midpoint. We're going to call the midpoint P. And if you guys remember, to find the midpoint, we simply take the average of the x's, average is adding them up, and then dividing by 2. So negative 8 plus 4, that's negative 4 divided by 2. And we get P equals negative 2. Same thing, add up. You get how much? Negative 2. Divide by 2. That's the average, and we get negative 1. So, if we now take the coordinates for P, from the origin over 2 to the left, down 1, we get our midpoint. Call it P. Now, to construct a perpendicular bisector, a little tougher. What we want to do is look at the slope of the line segment and then figure out that the perpendicular line has a slope that's not the same. There's a relationship. The relationship between the slope of the original segment and the perpendicular bisector is what's called an opposite reciprocal. Let me show you what that looks like. Let's first calculate the slope of segment AB. To do that, slope, I use little m for that. That's going to be change in y over change in x. As you recall, the notation delta is change, is subtraction. So we subtract our y values. Negative 3 minus 1 and negative 8 minus 4. Those are the x values. So reducing that, we get negative 4 as our numerator and negative 12 as our denominator, and that reduces, as you know, negative over negative is a positive, and 4 goes into 12 3 times. So we get a slope of 1/3. What that equates to is moving up 1 and right 3. Let's see if that works. From P, up 1, right 3 lands on the line. Up 1, right 3 lands on B. If you want to, you can go backwards. That would be down 1 and left 3. Down 1 and left 3. So this slope works out very nicely. Now to do the slope for the perpendicular bisector, you want to calculate what's called the opposite reciprocal. So clearly, with this being positive, the opposite would be negative. The reciprocal is when you flip the numbers. So the slope of our perpendicular bisector would be negative 3 over 1. Let's use that and go find the line. This is how I do it. Let's start at the midpoint, and it says go down 3 but right 1. So from this point, 1, 2, 3, right 1. 1, 2, 3, right 1. If I want to reverse that, that's going to be up 3 but left 1. Up 3 but left 1. If you notice, all the points are forming a nice straight line, so I might as well get my straight edge and connect it. What you now have is the picture of the perpendicular bisector. We're going to label that line L. We'll use a lowercase cursive letter, and now what we can say is the following statement. Line L is a perpendicular bisector of segment AB. Our congruent statement we can write now is that segment AP is congruent to segment PB. We also know that with this being a perpendicular bisector, we form a degree of 90 degrees all around. Something we could add later if we need to. Now that's supposed to be the easy part. So in backtracking, what we did first is we located the midpoint from our two endpoints by calculating the average of the x's to the average of the y's. Remember, average is adding the two and then dividing by 2. What we did from there, we wanted to calculate the slope of our line segment AB. That's change in y over change in x. So we subtract the y's, we subtract the x's, and we form our fraction. We reduce the fraction, we got 1/3. Remember, I double checked it as well. Then to get the perpendicular slope, we have to take the opposite reciprocal. That means take the opposite sign and flip it, reciprocate it. And we got -3/1. From there, I use my midpoint and I use my slope to find additional points that would form our line. -3/1 meant going down 3, right 1, and I did that a series of times. I also reversed it by saying going up 3, left 1 a series of times. Clearly, we were able to form our line. Now, that's supposed to be the easy part. The hard part is to build the equation, but maybe it's not so hard, maybe you remember. So to build the equation of the line, what we want to do is we need a point and a slope. And lucky for us, we have both. I'm going to use the midpoint because it's on the line, and I'm also going to use the slope I calculated when I found the opposite reciprocal. So the point that I'm using is point P, and that is -2, -1, and the slope that we found, which was -3. If you want to, you can write that as -3/1. And then I set up what's called the point slope form. That's y minus our y value equals m, I'm just going to use -3, our slope, x minus our x value. And then we solve for y and getting what's called slope-intercept form, or you maybe remember it as y equals mx plus b. So we get y plus 1 equals, distribute your -3, -3x, that's a plus 2, so that's a -6. And then one more step, subtract 1 from both sides, y equals -3x minus 7. And that is the equation of our perpendicular bisector. So that's a lot of work, and you'll be asked to do that on a series of questions that you'll be answering throughout this unit. So you'll want to practice it. So I have another question for you to try out. Have the following question. I have here a new segment going from the second quadrant to the fourth quadrant, and the endpoints are -4, 2 and 6, -4. What I want you to do is to construct the perpendicular bisector and find the equation of the line of the perpendicular bisector, just like we did in the last problem. So what you want to do now is pause your video, work on the problem, and I'm going to go through then the steps that you should hopefully come up with yourself. So pause the video if you like, or you can keep watching. Here we go. So what I did first is I found the midpoint. I found the midpoint by finding the average of the x's and the average of the y's. If you add 6 and -4, you get 2. Half of 2 is 1. If you add 2 and -4, you get -2. Half of -2 is -1. Here are some calculations to show that. So if I add that to my picture, 1, -1, that's right there. We'll call that point P again. And if you look, it's definitely halfway between C and D. Moving on. I now calculated the slope of segment CD because I'm going to need the slope for my perpendicular bisector. Again, it's change in y over change in x. Our y values are 2 and -4. I chose to start with the -4. -4 minus 2. And I have 6 minus -4. You could have started the other way. Here's just another option. Maybe you decide to start with a 2. So 2 minus -4 is 2 plus 4. And -4 minus 6 is -4 minus 6. Either case, reducing it 6 over -10, which reduces to -3/5. That is the slope along the segment CD. Next, all you have to do to find the slope of the perpendicular bisector is simply take the opposite reciprocal. The opposite of negative is positive. 3 and 5, you flip them, and you get 5/3. That now means from any point, if I want to construct the perpendicular, I move up 5 and right 3. Let's try that. From point P, 1, 2, 3, 4, 5, 1, 2, 3. If I go backwards, it's down 5. 1, 2, 3, 4, 5, and then left 3. 1, 2, 3. Looking at those 3 points, I have a nice line that is perpendicular to segment CD. We'll call that line L. Now, I ask you to find the equation outline. To do that, you need a point and a slope. Already calculated. Slope's 5/3, and the point is 1, -5. So I put that into my point-slope form. Here's a generalized form. Y minus y1 equals m times x minus x1. You put your point in for x1 and y1, and your slope in for little m. Here's a little tricky step that I show students. Your slope is 5/3, and people have trouble distributing 5/3. So try this out. Take your 3, your denominator, and distribute through on the left-hand side. Take your numerator and distribute through on the right-hand side. When you do that, you get the following. No more fraction, and you get 3y plus 3 and 5x minus 5. Now it's easy to solve for y. I would subtract 3 and divide by 3. I get the final answer of y equals 5/3 x minus 8/3. If you check that, my y-intercept is -8/3. That's about 2.75, but it's negative. That's pretty good. And my slope is 5/3, which we calculated earlier. I'm feeling pretty confident about that one. Hopefully you got the right answer. If not, maybe it's because you had some trouble with the 5/3, but this is a really cool little trick that I show my students, and it usually helps them out pretty fine. So, good luck, practice it, because you're going to be responsible for this throughout the entire unit. We'll see you.